So now we're going to look at a slightly more complicated version of rotated solids. Suppose we have two functions, f of x and g of x, and they intersect, and we want to take this intersected area, and that's what we want to rotate. And so we're going to actually have something that has a space in the middle, and then it will have this outside curve and this inside curve. And so this is a rather complicated shape. And so in order to deal with this, we have to think about the cross-section. Now the cross-section now is going to be something that we'll call a washer. The technical mathematical name for this would be an annulus. In other words, there's going to be an outside radius as well as an inside radius. And of course, if we have an inside radius lowercase r and an outside radius capital R, the area of this annulus is just pi r squared minus pi little r squared. In other words, it's just the difference of the area of the two circles. And of course, we could write this as A equals pi capital R squared minus R squared. And in fact, this is exactly what we're going to do for finding the volume here, because our differential volume will be pi times the outer radius function squared minus the inner radius function squared times dx. So let's be very careful here. R of x is the outer radius, and lowercase r of x is the inner radius. And what we're doing is we're squaring the outer radius and then squaring the inner radius, subtracting them, multiplying by pi, and that will give us the differential volume. Then, of course, what we do to find the volume is just integrate that, and integral from a to b, pi on the outside, outer radius squared, minor inner radius squared, dx. And this is washer method, sometimes also known as annulus method. Annulus is just a mathematical term for a ring, for a washer. In the next video, I will show an example of using the washer method.